Hello, everyone, and welcome to Power Hour for November. Excited to get this started today. Welcome. We're going to be talking about advanced math and logic today. My name is Shane Singleton. I'm the supervisor of the sales engineering group, and we have a special guest with us here today, Ben Gradsky. He is the supervisor of the project engineering group, the integrators. Say hi, Ben.
Hello, everyone.
Awesome. Welcome, Ben. So let's get started here. Like I said, we're going to be showcasing some applications using the Orion's Lua-based coding engine. It's called Advanced Math and Logic. You can do normal logic in it too. It doesn't have to be super complicated, very broad, very lots of things you can do with it. So to get started, even before we get off this title slide here, I want to launch a poll just to see where we're all at and make sure we're all awake early Wednesday morning or not that early. So I'm going to ask first, just generally, to see what you guys have done. Let's launch this one. I'm going to ask first which logic engines in the Orion you've used before, including advanced math and logic. So go ahead and give this a shot. Ben, you're doing a lot of integrating. I would ask for you, as we're talking about this, what do you see most customers ordering? Like, what are we working in most often out of this bunch?
I'd
Logic
say
Pack, 1131, AML, or Old Basic.
the the most common I would say is Logic Pack. It has a lot of simple applications you could use that don't require a lot of custom logic writing.
Okay,
But number two would be Advanced Math and Logic using custom Lua.
fair enough. Well, the audience, we have 70% voted. Well, I just went backwards. Someone unvoted. But let's give it just a little bit longer. Let us know what you're thinking. We're kind of seeing a trend here. So last call, click on something in the poll or don't, your call. And then we will share it about 5 more seconds here. Okay, let's close the poll and share what we saw. So actually most of you, by a good percentage, have used advanced math and logic or Lua the most. Okay, I did want to ask one other question now that we have talked about most of us having used Lua or more familiar with it. Let's talk about familiarity level. So kind of, I don't think these are official like software engineering terms or anything like that, but what's your familiarity level with Lua from those of you listening? So it's kind of silly. Journeyman Lua, apprentice Lua. Somebody clicked on less than 0. I love it. Okay, this can be a little bit shorter, but yeah. Good. I was hoping somebody would click on less than 0. That's funny. I know how you feel. So we'll close and share that poll here. All right, so we have kind of a bell curve in the middle here. So journeyman, apprentice, and then we have a few people that are quite good and a couple people that are pretty honest of having no idea what Lua does or is. So I think we have something to say for all of you here today. So that's going to be really cool. I want to point you all to the questions tab on your dashboard. You can see you should have a dashboard up since you are in this. We are actively looking for things to, like if you have a question as we go, you feel free to type it in there and we will either get to it in the chat or answer your question. And then also, I would like suggestions too. If you have something you want to hear about, it doesn't even have to be Lua related that we can cover in a future webinar. Just put suggestion : and then whatever you want to talk about. And we can address those as well. That would be greatly appreciated, actually. So if you think of something while we're talking about these varied topics, because we're going to be covering several things that we're touching with Lua, but they're actually utility applications, feel free to throw in a suggestion of something else you'd like to talk more about. So let's hide this poll and get moving. All right. Okay, so we're going to talk today about a couple of applications, places where we've used Lua. We're not going to write a 1,000-line program in front of you today and talking about how we could cover Lua applications but still keep it interesting enough to be a webinar, keep it short enough to be a webinar. We're going to highlight an algorithm or a logic flow or a special function out of each of those applications. That way we can talk about it, but not either put someone to sleep or lose the people who say less than 0. This should be something for everyone today. So you can see our 3 applications here. One of them, we automated a solar installation. We'll talk about that very shortly. Another one, we automated a distributed cat bank system. So customer had cat banks and they needed them to be automatically closed in or opened up. And then also a rail application that we've done as well, where we're automating that. And we used Lua in certain ways for each of these. So there's some overlap and some of them are kind of unique. So we'll try to cover a bit of backstory, the problem that we were solving, how we went about solving it, and then show you, actually, we're gonna do some programming in front of you, show you how to use Lua to solve it. So let's jump in. So we touched on this already. It's kind of defining it again here. Lua is a text-based language. It would be what you call object-oriented. If you want another language that's kind of similar to Lua, our advanced math and logic code that we use in our logic engine, might be Python. It's a higher level language. It's not super picky. You can do a lot of things on the fly that you can't do in other languages. And we're going to be sharing some applications of it today. So if you have some questions about what Lua is, what it does, throw it in the chat. And we will, I do see one suggestion in there, thank you. Throw it in the chat and we'll try to kind of park the car a little bit and answer them where we can. So we'll talk about the background of our first application now. All right, so application 1 was automating a solar installation. The background here, all right, picture of sun here. The background here is that an independent power provider joined a utilities generation grid. So they're required to let them in, the utility customer. So there's now a solar farm. So you have to bring the solar farm into your system as the utility and also control it as if it were your own, even though it's not. So one problem is they can't have any reverse power flow. And in this case, one of the jokes during this project was we don't want to be collecting any moonlight. So there were various reasons we would take the solar installation offline. So certain tags that we were considering were time of day, seasonal checks, general system health, so some things could go wrong there that you would trip off for, and then also recloser statuses and other permissive checks. The requirement, though, is the utility owns control of this installation, but they actually don't own the installation. And this is, some of you might have seen situations like this before, so might be familiar to you. So we're featuring, though, some logic here. And Ben, you might want to unmute, see if you're ready to go here. The feature would be some tables and comparisons within tables. And just a quick look, here was the whole flow chart on this one. We're not going to show you a flow chart for all of them because it's just a lot of chart. But if you can see my mouse, you would, on a 2-minute cycle, make sure it's enabled. You'd check what time of day it is. You would also check your blocking flags down here. And then you would do things like open reclosers or trip other things off like that based on a meter value, like the main bottleneck choke point meter for the whole solar installation. We would be reading that. And so they used an Orion for that and asked NovaTech to help. So If you want to take over, Ben, why don't you show us an example of something like this? And I might snipe you from the side here.
Sure, let me get started here. Sharing my screen. So thank you, Shane. We're not going to go into a lot of the specific logic that Shane was talking about. We're going to do a demonstration here. So this is a online Lua compiler that I use to quickly prototype code. I'll be using this to demonstrate some basics using tables, and the point here for this application was to highlight how tables can be used to compare and find values. That's a feature that we use in a lot of our Lua-based projects. And so follow along. I've started here with just how to create a table. So we have an element variable t, and these squirrely brackets are what define an actual table designation. So I'm just going to add in some elements into our table here. So we're going to start with some basic items here. So element 1 is going to have our apple. We're going to have a banana. Today was NovaTech breakfast feast day, so we have certain things on our minds. And so here we've defined a table T that has 4 elements, and we are going to try to print out our table so we can have, so in context, you would use this to print to the HMI screen or print out to the log. In this environment, we don't have access to Orion.printtable. We will use print as a function. So we can actually print out individual elements such as print table element 2. And if I execute this, we'll see that we get element 2, which was our banana. So this is our output. So to facilitate us printing, we're going to formulate a function call called print table, and we will print our table T. So I'm going to define a function. So functions are ways to encapsulate code that you're going to use on a repetitive basis. And so here I'm defining the print table function, and I want to print out all the values of my table. So starting with element 1 and proceeding to the size of my table, the hashtag is actually the size indicator. So this will print out from 1 to the size of table, which in this case is 4. And all I want to do is print, I want to see my iterator, I, and I want to have a space here, and then I want to print out my table element that is located in position I. And I will end the for loop, end that, and then when I run print table down here, since it's defined here, we should get a printout of all the elements in my table. First step completed. So now we have a table with elements. Say we want to locate a certain element in that table. We are going to define a way to search for the location of an element. So how would I go about finding, say, my apple location? These might be mixed up. These might be in different orders. As you see, the for loop is definitely a go-to when you're doing table searches. So I'm going to look through my entire table, and if I come across a table element that is the same as apple, I will want to do something. So we will print out a message to myself. Found apple at location I. If it hasn't found the apple, it will keep going until it finds it. And so now when we execute this, oh, sorry. This is what happens when you write code on the fly. So it gave me a little error there. Let's run that cleaner. Okay, so this is the print table result: apple, banana, orange, bagel, and this part of the function here, I found my apple at location 1, which is we could identify as correct. Apple was in location 1. And so this is the type of thing that we could use to dynamically search for places, things in your table structure. And so I have another function that I wrote here. I will copy this into the emulator here. So the next thing would be to be able to dynamically search your table using a function. And so the idea with this is I now have this search functionality built into this function search table. I could feed it a table value, a string value, and it will do the same thing that we just did with this for loop. So let me demonstrate a few steps here.
Quick question for you, Ben. This would
Sure.
be edifying for everybody. We have a question of where are the two dots coming from? I believe he means the concatenate function, but
Oh, so that's just me printing out a string. So for example, print table, I'm telling it to print the element I, so I could be, in this case, 1, 2, 3, or 4, and it prints out the table entry that is at location I. So in our case, our printout is just an emulation of these items here. So location 1 has element apple, location 2, element banana, so on and so on.
could you explain, would you say that they're kind of like the glue? You're like gluing different elements together there, that concatenate function. So you're adding a space, and then
Yeah,
you're
this is
putting
just
the table info.
so print expects you to have one string. And so this is exactly that, Shane. It's gluing together different elements to form one larger string element. And so in this case, 1 space apple is considered to be one string that print spits out on the screen. In our case
Thanks,
down
Ben.
here, found apple at location I, it's putting that in together as one big string for us. Does that make sense?
Yeah, that was great. And I'm also kind of typing that out in response to the question. So
Almost done with the example. So going back down here, so I have a function called search table, which does the same functionality as finding a certain element in my table. So in this case, we could have done search table is T, and then string would have been apple. So I could have inserted apple. It would spit out a similar result. And I built a larger encapsulating function called find item. And so now find item goes through and utilizes the search table function to locate an item, and it will tell me that either an item was found at the particular location, or the item was not found during the search. So now that we have these functions defined, I can use find item. T is our table that has all our items in it, and I want to look for a donut. No questions asked. So you see, we searched our table T. We're looking for this specific element. There is no donut in our table, so I got the message item donut not found. So now let's redirect our efforts, and we will look for an item that we know is there, banana. And so we would expect to see found banana at location 2. Sorry, the emulator does that. Let me run that one more time, clean it up. Okay, so we did not find our donut, but we found a banana and it's in location 2. So this is information that we could utilize during our logic sequence to do operations on specific elements, whether they exist or not in our structure. Just to
You could be
reinforce
looking
the
for
idea.
locking flags then in our
Flags, hotline
yeah.
tags, breaker type, relay types, all different device types. You may or may not have these things in various parts of your infrastructure, right? And so, yeah, there's our examples. We did not find a donut. We found banana at location 2. We found the bagel at location 4. Give me a second. Pardon.
Just had a question come in. One thing is we will include these little snippets of code afterward, as well as the link. You can see it here, but this online Lua emulator, it's way more fun to throw Lua in this than a $10,000 substation appliance. So yeah, that will be available. Thanks for the question.
Yes,
Cool.
I have this all in a document that we could disperse afterwards, so not a problem. So the last portion I've got here for this section is so instead of searching for these things individually, we're looking for a donut, banana, bagel. What if I just had a list of things? So I want to search using a list of items in a table. So I'm going to define an items list that we're going to use to search, and it's going to have various objects such as a hammer, I don't know, a pen, your phone. Let's see, orange, because you got to get something there that it will actually find, and a brush. So these, and I did not use the squiggly brackets. That's important. Squiggly brackets define the table. So this is definition of a table called items that has these elements inside it. This is another way to define a table. And so I want to use this items table and look for matches that are in our table T, which is up here, apple, banana, orange, bagel. So I want something to be able, a function to be able to tell me if it's found a comparison. So this is an introduction of how to use a generic for loop using the pairs iterator function. And so just a quick overview, it's similar to what we've looked at previously. This is just going through this list, which is going to be this items table, and we are going through key value pairs. And all the key value pair is hammer is the first key and the value is hammer. Pen is the second key and the value is pen, so on and so forth. So it's going to go through all of these items, and for each of these items, it's going to look in whatever table we send it, do you find a match? And print out found that element at location I. So it's going to tell us more information if it found things successfully. So just to show you, here is the items list. We're going to print out using our print table function the items list, which we've defined right here. So all this is going to do is repeat some information to us. Here's the items list. Hammer is in slot 1, pen is in slot 2, phone slot 3, so on and so forth. And this matches up nicely with our key value indexes. And so the last portion is we're going to add a print statement saying we're going to search for list of items in our table. The way we do that, we're going to call this function we defined, find items in list. And so it matters the order here. So table is going to be our table T, and the list of items that we're going to search for is called items. And so now when we run this, we should get a result for orange because we know that orange is in our table T. That should be the only match that we find. Sometimes you have to hit the button twice here. So here we go. Search for list of items in our table. We found element orange at location 3. So this is telling us that out of all of these items here, hammer, pen, phone, orange, and brush, we only found element orange, and it was location 3 in our table. So that kind of concludes this part of the demo. The point was just to show you a little bit about how table manipulation works in Lua and how you can use that to correlate information between different tables, and that lets you do a lot of powerful things in Lua for automation purposes.
Thank you, Ben. Yeah, that was really helpful. Okay. We have a couple of questions that popped in. 2 of them for you to be thinking about. Maybe quickly cover these, Ben, when we jump back to your next part. One is about error checking. One is about develop Lua in NCD or outside NCD. Okay, so our second application, we do have to keep moving because it's only 1 hour, like we talked about, but it was a distributed cat bank automation system. Some of you might have even heard this application before. And a SCADA system, but specifically the cat bank automation, they had a series of over a dozen cat banks distributed through their system. Let's show you the list of the criteria here. Over their system, they would have a lot of industrial customers, the machine load of which would dwarf their actual residential load, so they had a power factor problem, and it required constant vigilance to even with SCADA, bring these things in and out to keep power factor acceptable for their feeding utility. The utility, this municipal is a customer of a larger utility, and they would be penalized if they were off. So they were doing 20 to 30 manual interventions a day. It was not sustainable. So they needed automation. NovaTech stepped in and helped them with that. Kind of the idea was we would collect and monitor their metering data from protective relays, and we would use that data to engage capacitor banks or disengage. One trick here was they had 2 different substations that were being metered that were being critiqued for power factor this way. So we had to share that group of capacitor bank VARs that you could operate, which would mean that you could technically steal from the other station and cause problems. So we had to consider both at the same time. So it was a dual-threaded system. So we had a dynamic system for reordering and reassigning which assets belong to which substation as it was being automated. It's kind of a dual-thread system. So let's take this back to Ben, actually, and talk about these tables. So table reordering for dynamic cat bank allocation, that is the idea. Ben, I would ask, did you type in answers for those questions, or do you want to cover them?
I've been reviewing some of the questions, just quick comments. The one about error checking. Error checking would take a significant effort to add in here. I don't think we have the time to cover that, but the way the Orion handles errors, just real quick, if it encounters, like you're saying, you're doing an Orion.getPoint operation, and you insert a point name that's incorrect, that doesn't exist in the database, you will get an error, and it will halt your Lua process. You'll get an error in the log, and it'll tell you the line, line number of your Lua code that caused the error, but it kind of halts a lot of the processes going on. So you do want to be very cognizant of your get points, your set points, your Orion operations. Even just a Lua syntax error will cause a compiling error, and your logic will not run. So I'll type in a response to that next time. That came around kind of quick.
Okay,
um,
sure. Yeah, I can handle that. Why don't you go ahead
I,
and take the screen share back?
yeah,
And
I did like someone said you can do this on your phone with Sketch Lua. That is definitely valid.
um, and another interesting thing, definitely not the topic here. If you want to mess around with Lua and like use this online compiler, we'll have that in the notes that we send out. But you also can use any sort of like large language model AI and say, write me a script that does this if you're just wanting to mess around. I wouldn't load that straight onto your automation platform for your utility, but you can actually see some respectable Lua scripts and figure out kind of some functions. And of course, there's a manual for Lua that we will be including in the show notes as well. So, uh, all right, Ben, take it away.
And then, yeah, last note. There's a comment or two about developing in NCD or developing outside of NCD. This is just a prototyping tool. It's quick response, so it's easy to, you don't have to load it onto your Orion. We do have a better testing environment in the Advanced Methalua logic port now, simulator environment. So that is an option. Because I'd say it requires some learning. So uh, do at your own risk.
External text editors are okay too. Just make sure that you manage the files properly and don't overwrite yourself by accident. Um, so Ben's done
So
that a few hundred times. So
yeah. So back on point, application two. So we talked about the cat bank logic that we wrote for keeping track of volt var optimization for one of our customers. And the idea was certain number of feeders had access to certain cat banks at different times, and that could actually change throughout the course dynamically throughout the day. The user could actually go in and say, I want cat bank 5 to be operated by something else. A different feeder had control over it. So that would switch back and forth. And to do that, you need to be able to allocate assets in your tables dynamically. And there's a way that we're going to demonstrate this using the concept of we're going to have a set of rooms, and we're going to have people inside the rooms, and we're going to show you ways to take people out of one room and put them in another room, moving them around, and then show how that looks as you write code to dynamically switch assets between the different elements of the table. So we're going to find room one, and it's important to remember that this is going to be a list of elements. So we want room one to be a table itself. So we're going to have room one and room two for now that are lists of tables. So we have tables within tables here. And that is fine as long as we identify them properly. So we're going to use the table.insert function. We're going to identify in room one, we want to add Alice. Table.insert room two, and we're going to put Bob in room two. And then we could go back and say table.insert. We wanted to go back to room one, and we want to add Cynthia. So now Cynthia is in room one. I don't think that'll make a difference. Just to be sure, we're going to use the double quotes. I believe the single quotes work just fine. We'll just be consistent here. Consistency is good. And so now we have a couple of people in different rooms. We have Alice and Cynthia in room one. Bob is in room two. I want to know what's going on. So we're going to print out. We're going to put printouts of room one, and then we're going to use our print table from the previous example. It'll still be applicable here. Print table, and we want to print out room one. Let's see. And then we also want to print the occupants of room 2. And similarly, we will do with the capital. The capitalization of these function calls is important. So now let's see what this gives us. This should give us a list that says Alice and Cynthia are in room 1 and Bob is in room 2. And so here we go. Occupants of room 1. We have Alice as the first element, Cynthia as element 2. Occupants of room 2, we have Bob. And so when you find yourself just writing Lua or any code in general, if you find yourself doing repetitive tasks like this printing, I would recommend you investigate encapsulating this code into some kind of function call. We will do that shortly. I will show you, first of all, how to move someone from moving elements of tables from one to another. So say we want to move, I don't know, we want to move Cynthia from table 1 to table 2. We could go about that defining a temporary value, and we could use the function table.remove. And so this will remove the last element of the table from room 1, storing that information in our variable called temp. And so now we could use the table.insert, and we could say we want to insert an object into room 2, and that object is going to be temp. And then now we want to do this again. We want to see what the tables are now. And just to be clear, we'll put new occupants of room 1, new occupants of room 2. So let's see what the result of that is. So originally we had Alice and Cynthia in room 1, Bob in room 2. Now the new occupants of room 1, just Alice. And you can see we've added Cynthia into room 2. So this is the way we tracked in our VoltVar application of not only moving elements under control of different feeders, the order also mattered. So if we went to room 2, we would say we want Bob to do the work first because he's element 1. And when Bob did an operation, he either opened or closed in the case of cat banks, we would remove Bob and add him back to the list at the bottom of the list. So we actually had a dynamic ordering table to identify what the next cat bank should operate in a sequence. So we could actually kind of balance out the operations of the cat banks, equitably.
That was, yeah, we had to do that because otherwise it would just wear out the first one in the list. So we were balancing cat bank wear as part of the requirement.
Yes. So I have some predefined functions I will add. I'll add them one at a time. So the idea is, adding occupants to rooms. That's a repeatable operation that we're going to do. So I'll call this useful functions for our rooms. So, oh, it looks like I repeated myself there. Apologies. And so the first function here, I just called it add occupant. And you identify the table you want to add the element to. You identify the person in the form of a string. And this is a little bit of basic error checking. So this is checking to see if the table that you enter is actually of type table. That's a way to confirm that it's actually that sort of element. And same thing, we're adding persons in the form of strings. So this is verifying that person is actually type string. This is very basic. This isn't giving us any indication that something went wrong, but if these are not the right types of objects, of variables, it just won't do the insert function. So that's a low level error checking.
So if you had not done that and it had the wrong type, what would have happened?
We could experiment, and I'll show you that real quick. Before we do that, this is the print room function. So this is just another way of doing this operation and this operation in one encapsulated line. So let's do a table dot insert, and we're gonna define we're just gonna make a variable here called not a table, and it equals
Banana.
I was thinking
Oh,
Shane. Yeah.
we'll take Shane. Okay.
So we're gonna try to put something into not a table in the insert function, and we'll insert Tim. So we're trying to put Tim into not a table. It's going to give us an error. We'll see what the compiler gives us. Have to cook twice. And so this is an example of the error that you will actually see in the Orion log on the web UI. So it actually gives you, like, this is almost exactly what you'd see. You'd see main.lua. This is the main.lua environment here, line 49. So identifies the line number, and it tells you bad argument number 1 to the insert function. And so it'll tell you table expected got a string instead. And so it's telling you that the first argument of the table.insert function is not a table. It is a string, which is in fact what we see in front of us. So to fix this, we have to change this to a valid room, like room 2. Not a table could stay there because that's just a variable declaration. It doesn't impact anything. So now when I execute this, we have inserted Tim into room 2. So to end the section here using our functions that we've defined, let's do. Sorry, I was on the wrong screen here. So let's use the add occupant table function call. And so we want to add in room 2, we're going to add Shane. Shane, you're in room 2 now.
Okay.
We're going to add occupant. Let's see, let's do room 1. Now I'm going to room 1. And let's do print rooms as a function call. No arguments, it's just going to do what I've told it to do. And so it'll run new room occupants in room 1, Alice, and there I am. And then room 2, we have 4 occupants, Bob, Cynthia, Tim, and Shane. And notice that it stacks you in order as you're inserting them. So Tim was inserted before Shane, so Tim is element 3, Shane's element 4. And finally, say in the case that you want to add more, I don't know, feeders, more elements into your table, you could do that by defining in our room, we're going to add room 3, and we're going to define it as a table. And then we're going to add an occupant to room 3. It's important that you define room 3 as a table before, or else you'll get this similar error that room 3 is not a table. And then we will add our guest of honor, Chi. I don't know if she's here or not.
She just asked a question actually, so we'll get to that. I think we can camp out here just a little bit longer and we'll probably skip our third application.
Yeah, that's fine.
Since
Yeah, we're
there's
kind
questions here.
of running to the wall here. So just for
Yep.
the end example, we added a third element into our room table. We have room 3, and then here's the new list that prints out. So that's a way of using these add. I would probably make a remove occupant function or a move occupant function, and I can actually say move occupant from room 2 to 3. It will look something along the lines of move occupants from room 3 to room 2, something along those lines. So like I'd identify what occupant it was, what location it was, but that's the idea. I can make a function that does that for me.
Um, so the question here is, and we're trying to like be generic and talk about cat banks at the same time, so this might be
It's
a
kind of
little
tough.
bit difficult, but the question would be, let's say we closed a cat bank and it's no longer available. We were reshuffling this table. So let's say room 2 is not going to change. I'm looking at room 2 and Bob's number 1. We're gonna make Bob start injecting vars. Believe it or not, the the cat banks were named kind of close to this. They were named after streets, so it was kind of like this. But we're gonna use Bob and move him to the end of the list. So how would we do that to take room 2? Let's move Bob to the end of the list because we closed him in as a cat bank, and we want to record that he's going to be last on the list if we can help it.
So we're talking about room 2 operations, and I believe I put the number 1 here, and I believe that's going to pop off. So table.remove usually targets the last person on the list, but in this
Mhm.
case, by putting the second argument of 1, that's going to remove the first object. So I could remove first, second, third, fourth, whatever object I want. And so we're going to put him table. So we're going to use our add occupant function, because why not? We're going to put back in room 2, and we're going to put temp. And so let's print the rooms and see what that did. So we'll have another room occupants list here. Actually, to clean that up, let's take that one out. So we'll just have 2 iterations of the print room. Let's see what that looks like. So here's the first print room that is here after we added room 3 and we added chi into the mix. And then this is after the table.remove. We removed element 1 from table 2, which used to be Bob. So we grabbed him out of there, put him back on the end, add occupant room 2 temp, and now Cynthia, Tim, Shane, and now Bob is at the end of the list because we just operated Bob. That's an example of how that volt-var operation or code worked.
Okay, I'm answering one question here. He's asking about what standard package of libraries is included for the Orion. Lua Math or
I
Lua Matrix.
all the basics that are on Lua.org are available. Like all the functions that are described in the documentation on Lua.org. I believe we're on
We're on
5.3, right?
agreed 5.3. Yep.
So whatever documentation says that are built-in functions of Lua version 5.3 are available for use. I haven't encountered anything that's in that documentation that's not available on the Orion. I don't believe there's any additional libraries, but that's a topic that Shane and I discussed about talking about on this Power Hour, making your own library files. And it's a way to organize your logic, because these logic programs, this volt var, I think it came up to like 1,000 lines of code or something, Shane. I don't remember.
It
They
was
get
1,000 plus. Yeah.
they get quite large, and if you encapsulate that in libraries, it makes your life easier.
So that way you could just call a function and it's in
You
a different file, but you can still use it.
you just
So
call, yeah, you could call add occupant, but that could be in a library file in a different section, and you never have to look at what this actual code is. You just use the function call.
okay.
And there is an element called I'll put it up here on the top because you put these on the top of your code. It's pound include statements. So you do pound include, and you say I want to include library, and you would store that library.lua file somewhere on your Orion. Like it's same as any other Lua file. You would drop it onto the web UI through the files menu and load it there. It just lives there next to all your configuration files.
Okay. All right. Thank you, Ben. I
Sure.
will I will take this back here. And just a reminder to everyone else, everyone listening, if you have any suggestions again for something you'd like to hear about. I've seen a couple of them come in already, but if you have any suggestions, go ahead and throw them in the questions before we finish up here. So let me take the share back here, and we will talk about what's left. Okay. So thanks again to Ben. Really appreciate you dialing in on this one and joining us, even though you have lots of places to be and work to do. So much appreciated there. Want to highlight a couple of things. First of all, our customer community. This is a kind of a one-stop shop where you can find drawings, manuals, data sheets. There's also, you can get a link to here from the main website to get data sheets. You can find these power hours there, including all the notes all finished up. So if I saw a question about 61850 as a topic. If you want to learn about 61850, you can type that in the customer community, and there will be multiple webinars about that and resources toward that. So that is the community site. Use it all the time. I would, yeah, definitely check that out. Similar, but not exactly the same, the customer support site. This is your one-stop shop for your latest NCD downloads, your Orion OS distros, firmwares for Bytronics and Kronos, and future products. Stay tuned, everybody. We have some exciting stuff coming very soon. And then also our file share is on here. So if you are working with NovaTech engineers or just for yourself, you can actually put files on here. Often tech support will send you large files. So that is done through your support site login. And of course, we have all of your Orions tracked on here. Another important site to remember is the booking site. Yes, and I see your question here. We'll look at what original code we can share. Some of it belongs to the customer, but the booking site, if you want to talk to me or one of the other application engineers, you can go to the Orion booking site, and this will actually access our calendar, choose a time, and we'll hopefully through a Teams call, we can do phone call too, have a discussion about whatever you want to talk about, some application that you're working on. We also, of course, have a tech support line you can find from our main phone number. Just ask for tech support. Okay, and then one last check on questions. The specified speed and processing time for the logic engine. Okay, so I've seen this asked before. There's not a specific time. It's on the Orion, you can think of it as first in, first out. We rely on, I believe, processor overhead. So we will have enough processing to do the work immediately on this. I've really loaded up Lua before and not really slowed it down, but it's what you would call some people would say not exactly deterministic. So it would maybe vary in a millisecond or so in either direction each time, but it's hard to do mathematically, but we could test that if you had a really specific application. But yeah, that's kind of what we have here. Thank you all so much for joining today. Again, my name's Shane. We had Ben Gradsky with us today. Really appreciate you all, and hope you learned something today. Notes for this will be included within about a week. So we will be able to get you your questions listed out, and then also resources such as the Lua manual, some example code that you saw today, and any resources that we think might be helpful. Thank you all so much, and have a great rest of your day.